So in this video series, we're going to learn about vectors, and we're going to learn about vectors in the scope of a physics class. We'll be learning about adding vectors together, subtracting vectors, learn about things like the dot product and the cross product, basically everything you need to know about vectors to succeed in an engineering physics course. And before watching this video, you want to make sure you're good with trigonometry. You want to make sure you're good with sine, cosine, and tangent, and the unit circle. So, what is a vector? Basically, every word that you read about or hear about in physics will either be a vector or a scalar. So a vector is something that has magnitude and direction. And an example of a vector is force. For instance, we may have this crate on the ground, and we could try to push the crate to the right with a force of maybe 10 newtons. So force is a vector because it has magnitude, which is how much. So this force vector has 10 newtons. That's how much force we are applying. And the direction is to the right. Another example of a vector may be a change in a position, which is formally known as a displacement. Let's say I start here, my initial point, and I walk over here and end up here at my final point. This movement, this change in position, is also a vector. If I traveled 13 meters, that's my how much, that's my magnitude. In my direction, it looks like I'm traveling northeast. So basically, every concept, every word you come across in physics will either be a vector or a scalar. So we talked about vectors. A scalar is just something that only has a magnitude. And an example of a scalar is temperature. Imagine I have some gas in a container, and this gas is very hot. Well, it's not like this idea of temperature, hotness has a direction. It's not like it's going, any which way. Temperature is only described by a how much factor. It can only be described by one number. Like the temperature of this gas may be 72 degrees Fahrenheit. Another example of a scalar is mass. Mass is basically how much stuff, how much matter is in an object. So here's this crate. It's almost like counting up how many atoms there are in this object. So this crate may have 15 kilograms of mass in it, of matter. And of course, this quantity doesn't have a direction either. We're just counting up how much stuff is in this crate. So scalars are things or ideas that can be described with just a magnitude, just a number, just a how much. While vectors are more complicated ideas in physics. Things that not only have a how much aspect, but also a direction. In a way, a vector is a thing that can be described with two numbers. The magnitude is our 10 newtons in the case of the force, and the direction, that's usually described using an angle theta. And usually that angle is measured from the positive x-axis, but that's a usually. It all depends on what the directions say, but usually the direction of a vector is measured from the positive x-axis. So for a force vector, if I drew a positive x-axis from its base here, its angle would be 0 degrees. And for this one right here, for a displacement vector, its angle might be 45 degrees. So every concept that you read about in physics will either be a vector or a scalar. And of course, this video is about vectors, so we'll be focusing more on vectors. And just one thing I want to say before I forget, let's say that this force, 10 newtons, is F1. This arrow symbol, that means F1 is a vector. So that is force 1. And if I do this, if I put these absolute value signs on it, it means the magnitude of the vector, which in our case is 10 newtons. So know that this symbol means the magnitude of a vector. And the magnitude of the vector will always be just a number. It doesn't have a positive or negative on it. It's sort of a signless number. Some people say that the magnitude of a vector is always a positive number. Yeah, I see what you're saying, because if you just write 10, it's kind of assumed that there is a positive there. So I see what they're saying, but I like to think of the magnitude of a vector is just a number without a plus or minus. Pluses and minuses come in more when we start talking about the direction of a vector. A really important theme in learning physics is that pluses and minuses are really nothing to be afraid of. They just convey information about the direction. A plus may mean, a force acting to the right, while a minus might be a force acting to the left, Or a plus might mean I'm giving energy to some system, while a minus might mean I'm taking energy away from a system. So pluses and minuses have more to do with the direction of a vector. The magnitude of the vector is always just a straight up number. There's no plus or minus attached to it. But be aware that, some people say that the magnitude of a vector is always positive. And yeah, I see what they're saying there, because if I just put a number here, it's kind of, by default, since there's no negative, there's a positive. You'll also want to know that while we give the direction of a vector in terms of some angle, which we can clearly see just by drawing the vector on a piece of paper, the magnitude of a vector is sort of symbolized by the length of the vector that you draw on a piece of paper. So if I wanted to try to pick up that crate, I would need more force, right? I might need, 15 newtons. So to symbolize that on paper, I would draw 15 newtons going up, and I would make sure that this vector line here is longer than my 10 newton force vector line there. So even if we didn't see that 15 newtons and that 10 newtons, on paper, I could still tell that this force is stronger than that force, because that 15 newton force vector, the length of it is longer. So when you're drawing vectors, use the length of that vector line to symbolize whether a vector has a strong magnitude or a weak magnitude.